let's think about what the area underneath a velocity time graph represents. So if I just draw any random horizontal line and then let's just do a slope like that. Let's think about what the area underneath this entire graph is. You can see we kind of have a composite of two shapes. We have a rectangle and a triangle. You know that the area of a rectangle is length times width, and you know the area of a triangle is 1/2 base times height, or base times height divided by 2. To calculate the area, let's just look at what each of these is. So if we were to set the length here, or the base, as our time, this is the length for the rectangle or the base for the triangle, and the y-axis, let's say, is just our width, doesn't really matter, and the height for the triangle. Let's just see what we would get here. So for the rectangle, length times width, the length is time, and the width is velocity, which is a vector. Should be showing my vector arrows. What happens when we multiply velocity times time? How would we figure that out? Well, there's a couple methods you could use. You know, the dvt triangle, maybe. I know a lot of people use that. Velocity times time equals displacement. Another thing people sometimes use is a unit analysis. So we have a times, which is seconds, times a velocity, which is meters per second. And you can see with fractions, these seconds would cancel, leaving us with meters. And from that, we would confirm that this is a displacement. Either way, it doesn't matter. We have a displacement, which is a vector quantity. Now let's show the same thing for the triangle. Triangle is 1/2 base times height. The 1/2 doesn't really matter for the quantity we're going to end up getting. The base, we said, was the time. So we multiply time times the height, we said, was the velocity. And who cares about the half? We're just looking at time times velocity. We did that already. Time times velocity, you could see, is displacement using either the triangle or the unit analysis. This is a displacement.